Section 1 Introduction. We're here to discuss the recent progress in large language models, LLMs, which have sparked a lot of interest due to their impressive ability to follow instructions and handle a wide range of situations. Researchers have been using open-source LLMs like Opt, Flan T5, Llama, and Pythia to develop ways to make these models better align with human preferences. This is done through a process called instruction fine-tuning. The result? Models that understand human instructions better and provide more coherent responses. However, there's a problem. Current benchmarks and traditional metrics aren't quite up to the task of accurately measuring the capabilities of LLMs in open-ended scenarios. This has led to a need for a new benchmark method that can fully evaluate LLMs in these types of tasks. There are ongoing efforts to find different ways to evaluate the performance of LLMs. Some methods use a competition format, where anonymous results from LLMs are gathered from crowdsourced platforms. While human evaluations are reliable, they can be time-consuming and expensive. Some methods use GPT-4 as a judge, but these methods face challenges such as potential data exposure and unpredictable changes in the API model, which could affect the reproducibility of the judge. Panda-LM is another approach that fine-tunes open-source LLMs to evaluate answers. However, this method has its own limitations, such as the size of the model, the quality of the training data, and inherent biases in the LLM, which can undermine the effectiveness of the fine-tuned models as judges. In this paper, we propose a new way to evaluate LLMs using fine-tuned open-source LLMs as judges. We call them JudgeLM. These judges are scalable and agree well with the teacher judge. Our method uses these scalable judges to evaluate open-ended tasks and uses a high-quality dataset that is good for both training and evaluating the judge models. We adapt open-source LLMs to serve as judges and analyze their ability to scale in relation to the size of the model, from 7 billion to 33 billion, and the amount of training data, from 3.5 thousand to 100,000. Our dataset includes 105,000 seed questions, LLM answer pairs, and judgments from the teacher judge, GPT-4. We generated 2 judgments for each seed task, one with reference answers and one without. We divided this dataset, with 100,000 seed questions used for training and the rest for validation. Using LLMs as judges does introduce some biases, such as favoring answers in specific positions, over-reliance on pre-trained knowledge, and optimal performance only under specific prompt formats. We propose methods to address these biases. Our JudgeLM system has extended capabilities, including grading single answers, judging multiple answers, judging multimodal models, and multi-turn chat. Compared to competition format methods, our approach is faster and cheaper. For example, a model like JudgeLM 7B only needs 8A100 GPS and can evaluate 5,000 response pairs in just 3 minutes. Compared to closed-source LLM judges, JudgeLM ensures reproducibility and protects user privacy. When compared to other open-source LLM judges, our system explores both the scaling ability and biases in LLM fine-tuning. Plus, the dataset we introduce is the most diverse and high-quality one yet, which will greatly benefit future research in judge model investigations. Our main contributions are as follows. 1. We introduce a high-quality, large-scale dataset for judge models, enriched with diverse seed tasks, LLMs-generated answers, and detailed judgments from GPT-4. This lays the foundation for future research in evaluating LLMs. 2. We propose JudgeLM, a scalable language model judge, designed for evaluating LLMs in open-ended scenarios. It achieves an agreement rate of over 90%, which is higher than the human-to-human agreement rate. Our JudgeLM also has broad capacities to deal with extended tasks. 3. We analyze the biases inherent to LLM judge fine-tuning and introduce a series of methods to address them. Our methods significantly improve the consistency of the model in different cases, making the JudgeLM more reliable and flexible. With the development of LLMs, researchers have found that fine-tuning pre-trained LLMs like GPT-3, T5, Opt, and PaLM can help LLMs follow human instructions and assist with open-ended tasks. The fine-tuned LLMs show a stronger ability in zero-shot or few-shot tasks than their base models. After Meta released the powerful open-source LLM Llama and Llama 2, many fine-tuning works based on Llama or Llama 2 were proposed in the natural language generation or multimodal generation domain. Our JudgeLM also belongs to the Llama family and takes the Vicuña series as base models. Our JudgeLM follows the instruction fine-tuning manner to create LLM judges and proposes to model the judgment generation task as grading, judging, and reasoning. We also collect a high-quality, large-scale dataset for research in judging the performance of LLMs. Section Summary. Recent advancements in large language models, LLMs, have led to the development of methods to align these models with human preferences through instruction fine-tuning, resulting in enhanced abilities in comprehending human instructions and generating coherent responses. However, existing benchmarks and traditional metrics do not adequately evaluate the capabilities of LLMs in open-ended scenarios, necessitating the need for a new benchmark method. In this paper, we propose JudgeLM, a scalable language model judge that achieves high agreement with human judges, addresses biases inherent to LLM judge fine-tuning, and introduces a diverse and high-quality dataset for future research in LLM evaluation. Section 2.2 Evaluation of Large Language Models. We're going to discuss the evaluation of large language models, LLMs, and the creation of a dataset for this purpose. 2.2 Evaluation of large language models. With the rise of open-source large language models and their fine-tuned versions, assessing their capabilities has become a challenging yet popular task. Chatbot Arena is trying to tackle this issue by creating a platform that ranks these models based on comparisons and ELO ratings. However, this crowdsourced approach, while reliable, is costly and inefficient. Vicuña, on the other hand, uses GPT-4 to select the best answer, mimicking human expertise. But this method has potential risks, such as data leakage and unstable performance. XenoBuild suggests evaluating these models using a customer service dataset, but traditional metrics like CHRF and BERT score can't fully assess the model's responses in open-ended tasks. PandaLM has developed a model based on Llama to compare answers produced by these models. While it performs well, its model size of 7 billion parameters limits its performance. Our model, JudgeLM, ranges from 7 billion to 33 billion parameters and outperforms both PandaLM and our benchmarks. Plus, researchers can use JudgeLM locally, ensuring reproducibility and data security. 3. Dataset. Creating high-quality, large-scale datasets is crucial for fine-tuning these models to act as evaluative judges. However, existing datasets have limitations in terms of diversity and judgment criteria. To address this, we've created a new dataset filled with a variety of tasks, comprehensive answers from modern LLMs, grades from the teacher-judge, and detailed judgment reasons. 3.1 Data generation. Our goal is to create a large and diverse dataset that enhances the evaluative capabilities of judge models. We've sampled 105,000 tasks from a large set that includes Alpaca GPT-4, DALL-E 15K, GPT-4 All LAION, and Shared GPT. To increase the dataset's diversity, we've collected answers from 11 leading open-source LLMs, including Llama, Alpaca, and Vicuña. We then combined these answers with the reference answer to create answer sets. From these sets, we randomly selected pairs and assigned them scores and detailed reasons using the advanced teacher model, GPT-4. 3.2 Training and evaluating. We've divided our dataset into a training set of 100,000 samples and a validation set of 5,000 samples. During training, JudgeLM is given a question and a pair of answers, and it produces scores and detailed reasons. The input templates vary depending on whether there are reference answers. We've fine-tuned JudgeLM with sizes of 7 billion, 13 billion, and 33 billion parameters, and on varying data scales, demonstrating its scaling ability. For evaluation, the judge model first generates scores for answer pairs. The result is determined based on which answer has a higher score, or if it's a tie. The model can also generate detailed reasons if needed. We use objective and reliability metrics to evaluate the models. Objective metrics measure the agreement, precision, recall, and F1 score between the model's results and those of the teacher. Reliability metrics compare the results before and after swapping LLM answers and measure the model's consistency. We also calculate metrics like bias toward first, bias toward second, and delta bias to understand specific position biases and their variance. Section Summary. The evaluation of large language models, LLMs, is a challenging task, and various methods have been proposed, including crowdsourcing, GPT-4-based judging, and traditional metrics. However, these methods have limitations such as high costs, data leakage risks, and inability to fully evaluate open-ended tasks. To address these issues, we propose JudgeLM, which contains scalable judges and achieves state-of-the-art performance. We also introduce a novel dataset with diverse seed tasks, comprehensive LLM-generated answers, and detailed judgments to effectively train and evaluate judge models. Section 4: Inherent Biases. In this paper, we delve into the inherent biases that can affect the reliability of fine-tuned language model judges. We use metrics and visualizations to illustrate these biases. Firstly, we discuss position bias, which is the tendency of language model judges to favor answers in a specific position. This bias is common in natural language processing tasks and human decision-making. Even powerful language models like ChatGPT and GPT-4 are not immune to this bias. Our results show that our model, JudgeLM, also exhibits position bias, often favoring the first answer when the positions of answers are swapped. Secondly, we explore knowledge bias, which occurs when the pre-trained data lacks information about certain tasks or includes potentially undesirable information that could limit the generative capabilities of language models. For instance, if a language model judge lacks relevant knowledge, it may not be able to accurately judge open-ended tasks. Thirdly, we examine format bias. Ideally, a judge model should be able to make judgments based on pre-trained knowledge when no reference is available, and follow the reference when one is available. However, our experiments show that judge models tend to prefer the fine-tuning format, regardless of whether a reference is available or not. We call this situation a mismatched format. We believe that format bias occurs because judge models are overfitting to the fixed fine-tuning template format. To evaluate the answers generated by language model judges for a given question, we present JudgeLM, a scalable judge model that addresses these inherent biases. We use a method called swap augmentation to mitigate position bias. This involves judging twice, once in the original order and once in reverse order. If the judgments differ, we consider it a tie. This method doubles the evaluation time and is more of a compromise than a solution to the inherent position bias of language models. However, by swapping the positions at the fine-tuning stage, we can encourage the judge model to focus more on the content of the answers rather than their positions. To compensate for the lack of pre-trained knowledge, we introduce external knowledge through a method called reference support. We collect reference answers for all judge samples and use them to guide the judgments made by GPT-4. This helps to avoid factual errors and produce reliable judgments. To address format bias, we introduce a method called reference drop, where we randomly drop the training sample with a reference and use the corresponding sample without a reference. This helps to reduce overfitting for fine-tuning formats and allows for fair judgments with or without a reference. We then evaluate the performance of JudgeLM, comparing it with other methods, analyzing its scaling ability, and conducting detailed ablation studies of the proposed methods. Our results show that JudgeLM outperforms other models in all metrics, demonstrating its powerful judgment ability. We also evaluate the efficiency of JudgeLM compared to other models. Our experiments show that JudgeLM is more flexible and efficient than other models. For example, using GPT-4 to evaluate on the JudgeLM validation set costs approximately $60, while JudgeLM accomplishes the same task for just $0.5, representing just 0.8% of the expense associated with using GPT-4. Section Summary. In this section, the paper discusses the inherent biases that affect the reliability of fine-tuned language model, LLM, judges. These biases include position bias, knowledge bias, and format bias. The authors propose methods to address these biases, such as swap augmentation to mitigate position bias, reference support to compensate for knowledge bias, and reference drop to alleviate format bias. Experimental results show that the proposed JudgeLM model outperforms other methods in terms of accuracy, precision, recall, and F1 score, while also being more efficient and cost-effective. Section 6.2 Scaling Analysis of JudgeLM. In this section, we'll delve into the scalability analysis of our model, JudgeLM, and its performance on our validation set. As we scale up the model size and data, we see a corresponding increase in performance metrics. This shows that JudgeLM is highly scalable, achieving up to 90.06% agreement and 87.93% consistency with a model size of 33 billion parameters and 100,000 fine-tuning data. Next, we'll discuss the results of our ablation studies, where we tested different components of our methods. For these studies, we used a base model of JudgeLM with 7 billion parameters and 3,500 fine-tuning data. We then examined the impact of 3 different factors: swap augmentation, reference support, and reference drop. Swap augmentation proved to be a valuable addition, significantly improving the model's consistency by 5.44%. This suggests that swap augmentation can help reduce position bias and encourage the model to focus more on the content of answers. Reference support also enhanced the model's performance across all metrics. This indicates that incorporating reference answers can help the model draw on external knowledge and overcome the limitations of pre-trained knowledge. The reference drop feature also improved performance, particularly when dealing with mismatched formats. This feature allows JudgeLM to handle formats with or without references and achieve higher agreement and consistency. It suggests that reference drop can help mitigate format bias and prevent the model from overfitting to a single format. Beyond judging answer pairs, JudgeLM can be extended to a variety of other tasks. These include grading individual answers, judging and ranking multiple answers, evaluating multimodal models, and engaging in multi-turn chat about judgments. For grading a single answer, we modified the template slightly to allow JudgeLM to provide a quantitative, fine-grained evaluation. This is a departure from the usual method of judging pairs of answers to determine which is better. When it comes to judging multiple answers, other models require a significant number of calls to get the full matrix, which is inefficient. We addressed this by extending JudgeLM to process multiple answers simultaneously, again by modifying the template slightly. For evaluating multimodal models, JudgeLM offers a good solution. Traditional evaluation methods require an exact match with the ground truth, which is not always possible with open-ended questions. JudgeLM, with its ability to judge open-ended answers, performs well in this context. Finally, JudgeLM retains the ability to engage in meaningful dialogues with users, providing rich context, detailed information, additional examples, and specific details. This is despite the fact that fine-tuning with judge samples does not compromise the multi-turn chat ability extended from base models.